All right, welcome everyone to the second session of the Speech for Social Good workshop. We're going to start this session with a panel on data collection, bias, and ethical concerns in speech processing. And we have a wonderful panel, including Sakriani, Gopala, Odette, and Emily, and it's going to be moderated by Alan. So without further ado, I turn the virtual mic over to you, Alan.
Hello everyone. So we're going to have a panel session. There's a bunch of predefined questions which the panelists have seen, but for those of you in the audience who want to ask questions, feel free to do that, particularly follow-up questions, because I won't know if you have those. So you can type them in the chat, you can raise your hand, and maybe you might have to shout to make sure that you have that. So what we're going to do is we're going to have first each of the panelists give a short intro about themselves and their relevance of their work to speech processing for social good. So in no particular order apart from the order they appear on my screen, which might be the same order that they appear on your screen, I'm not very sure. Let's start with Sakti Sensei.
Okay, so hi everybody. So I'm Sakriani Sakti. I'm currently an associate professor at Japan Advanced Institute of Science and Technology in Japan. So in terms of spoken language processing for social goods, I mainly focus on the low resource language. So now I'm also a chair of ELRA and ISCASIC on the under-resourced language. So I'm organizing several workshops for under-resourced language like SLTU, Digital Revolution of Under-Resourced Language, and also organize the LT for All, which is this is together with ELRA and UNESCO. This workshop is not like a research workshop, but the way we connect to the indigenous community and get the feedback. Okay, I think this all.
Okay, thank you. Let's move on to Gopala.
Hi all, very happy to be here. Thanks for the invitation, Alan and Anurag. So I'm an assistant professor at UC Berkeley in electrical engineering and computer science, and at UCSF in neurosurgery. So my background is well, I was trained at CMU with Alan in speech synthesis, and I have since moved to something more sciencey to understand the basis of human speech production and perception in the brain. So the kind of social good work that I'm doing now is very much in the health applications at this point. So these are conditions, neurological conditions that progressively impair someone's ability to speak. Or conditions like dyslexia or aphasia, like these could be sometimes chronic, sometimes occasional, seasonal things, and sometimes these are completely locked in patients who do not have the ability to speak or move. So I'm looking. So this is really in the long tail of spoken language, broadly speaking. So my work is really how can we create technology that brings them also into the fold of spoken language processing and enable them to communicate again with whatever residual function they have, or for diagnostics in cases like dyslexia or aphasia. Right, that's all about what I do.
Okay, thank you. Odette?
My name is Odette Scharenborg. I'm very happy to be here. I just returned from Korea from Interspeech. So we actually organized a special session there on fair and inclusive speech technologies. Myself, I've been working on low resource languages for 4 to 6 years, primarily in automatic speech recognition. For the past 2 years, about 2 years ago, we started a new research line, which I've called inclusive automatic speech recognition, where we're trying to quantify the bias in different type of ASR systems, focusing on gender, regional accents, non-native accents, age. We're also working on dysarthric speech quite a bit, voice conversion and automatic speech recognition. So we've been working in low resource speech styles and speech and languages for quite some time now. Yeah, and on top of that, I'm the ISCA vice president, and also from that position, I'm also trying to, to reduce bias, not only also against particular minorities, so minority groups, trying to make sure that our community is more inclusive, has more regional balance, more gender balance, etc. So it's not only from the speech side, but also from the speech community side. I'm working on this.
Okay, thank you. And Emily?
Yeah, hi everybody. I feel like I think I'm the only grad student on this panel, but I'm I guess I'm in my 4th year now at the University of Washington in the linguistics department. I worked with Alan in my master's at Carnegie Mellon, and actually just a brief thing, Odette, I remember in terms of things that you've done for social good, I think you helped host the 2016 workshop at InterSpeech, like women.
2017. 2017, yeah, and 18 and 19, I think, something like that.
Oh, okay. But I attended it 16 in the fall.
Okay, yeah, I was there as a mentor.
Yeah. So I was there, not yet a grad student, and I benefited by looking up to amazing women like you. So thank you for doing that. In terms of some things I worked on along the lines of speech for social good, I guess I did more some text-based things early on, things like detecting microaggressions in social media with our ethics and NLP class, Alan, and studying code switching and trying to, making that technology accessible to people that actually do code switch as a diverse way of speaking. But then more recently here at UW, a couple of projects I've been on. One was an NSF grant with Gina Laveau and Emily Bender with looking at so it was in Compute EL, the Endangered Languages workshop, and we're trying to develop shared tasks for speech processing, namely speaker diarization and speaker ID for certain endangered languages, and trying to promote that as, shared tasks is a great way to get people, the community involved in things that we want to really focus on and care about. And currently I'm trying to do some work on understanding language universals around phonetics and how sound systems are similar or different, I guess. So this is like a typology, phonetic typology, and how we can both understand things about language and then also, sorry, I kind of lost my notes. Then that should benefit the technology as well. So like a win-win type of thing. Looking at large speech corpora like the wilderness data set, as well as common voice, things that are out there that we can use. So I think that that's about it for me.
Okay, thank you everyone. So we're going to give questions, and we'll probably get you to speak in different orders each time if I can remember. And so the first question is about data collection and bias. Given that we're working in typically low resource, whether it be that endangered language or for medical reasons, there's limited numbers of patients, etc. What are the consequences in data collection and bias in data collection that are important to care about when dealing with speech for social good? So let's start with Odette.
Okay, there's a long question. I also have the questions open here, but I think for me, when I look at data collection, especially for speech types that are currently under-resourced, then like for instance, I call it for medical applications, health applications. I think the biggest issue is that you will always only get a small portion of the group of people that you want to develop speech tech applications for. For instance, if you want to record people who have dysarthria, you will only get a few of them who want to cooperate. And the problem there is that there is such a huge variety, for instance, in dysarthria or in oral cancer. So we've also worked in oral cancer speech. There's such a huge variability in the type of speech that people that create that you will never get a good representation of the type of speech, or at least there's a big chance that you will never get a good representation of the type of speech that you might actually encounter so the type of dysarthria or cancer speech, etc., that you might encounter in real life. So the biggest issue, I think, is that you will always have some kind of bias, at least that's my worry, simply because the variability of the speech types, whatever the speech type you're looking at, is so high, so much higher than we typically see in typical speakers, that it will be really hard to collect data that is a very good representation of all the variability that you might encounter. So I think for me, that is one of the biggest issues, I think, in terms of data collection of atypical speech.
Okay, thank you. Emily?
Yeah, I was just trying to think about how we can work towards that. That's a hard problem indeed. Yeah, I mean, well, I guess I thought the question was how do we fix these things, and I was like, I'm not sure. This is a very challenging thing. I guess thinking kind of far off. Are there certain incentives we can have to have more balanced data sets, more diverse data sets? It's hard, right? Yeah, so no answers here. I just but I can speak to some work. Well, I won't go into any detail at all, but I just finished internship with Amazon Health, or actually it was Care before, and then it shut down and became Health. And we worked with a lot of data that was mock. So like actors that were enacting conversations between doctors and patients. And I think that was a very, well, that was kind of new to me. I thought, oh, why not use real data? But yes, there's tons of privacy concerns. So I think it was an interesting way to go about trying to collect data for sensitive topics by using, actors, I suppose. But like, I don't know, in reality, I feel like that would take tons of money, take tons of time and resource. So I'm not sure if that is necessarily a thing that everyone can just do.
Okay, thank you. Sakti?
Okay, so I think in terms of technology, how we deal with the bias data, maybe I don't know whether we can do some like data augmentation or something like that. But in terms of the community involvement, this is usually the critical issue, because most of the time we are work based on the project, that the project is only like maybe 3-5 years with the limited budget. So we cannot collect many things, right? So for example, like when I start doing the low resource language, I'm basically from Indonesia, so I work on the ethnic language in Indonesia, and it's difficult to collect it in the real ethnic language, because the place is very distant. So then even we ask the community to help, it's still difficult. And then when I ask the government to help, they don't think that this is necessary, So I think the main things is the awareness that this is important. So then they're willing to do, and the government help. And this is why, in the end, I try to connect with the UNESCO, because I think like when UNESCO say, like everybody try to listen, and then now when connect to UNESCO, and then UNESCO get to the government official and the community by themselves, and finally they are somehow realize that this is important. And then now in Indonesia, like START is growing everywhere, like many activities of doing this. So I think the important is the awareness, like why this data important, and then why we need to do like this. So because sometimes the community itself doesn't understand why they need the technology, and and it's vice versa. So I think the communication and the awareness is important in this case.
Yeah, awareness, I think, is getting people learning about it is as much the problem as actually addressing it. It helps. So, and Gopala?
Yeah, great points across the panel. Yeah, so the issue of bias is inevitable, as rightly pointed, and there is no obvious solutions. But I think the things that we can do are, kind of things that were mentioned, but largely I think it should be addressed from, how are we getting the data kind of scenario. Uh, I think the biggest problem is we do not have multidisciplinary teams in collecting data. So the engineers care about what they care about, and the community workers care about what they care about. And the users have their own, perspectives and prejudices. And so I think a good data collection strategy must involve all the stakeholders such a way that there is good design decisions happening, so that there is a lot more engagement from the community. And this is true across the board in all the low resource settings, be it like indigenous languages or be it health. The kind of awareness that Sakti was talking is important as well, and good design practices in an app that's eliciting this data. It should not be too daunting. It should be welcoming for people to like. And these are not easy things to do. I think with more stakeholders thinking about the problem and working with the community, I think is the best idea. I'll give you a specific example. In EEG, for example, EEG is like the sensors that are placed on the head to get at the signals. The engineers generate these things, these sensors, but they do not work on, say, too curly hair like the African American hair, right? So it just is this disconnect between who is the user, who is what their assumption, what the engineer's assumption of the user base is, and so they're basically alienating communities just by the choices they're making. So I think more awareness on the part of people, but also on the part of the designers of these studies and illustrations is important. And despite all this, I think by design, the long tail in language tech exists and will exist, and we should respect it as such. So I think we should have from the data side, we can battle this as much as we are talking about here. But on the modeling side, we should talk about things like incremental learning or ambiguity detection, like models that are more aware that there is a long tail and there may be some bias in the model, so that you're also giving more confidence measures in terms of what the model is aware of and what it's not very confident about, and have like continual learning strategies that grow more and more inclusive in time, rather than these black boxes that are just not working. So yeah, those are my thoughts right now.
Okay, thank you. That's quite a varied but interesting answers from you all. Let's move on to another question. And instead of being at the data collection end, let's talk a little bit more about the computational end, and so talk about the modeling. Most machine learning nowadays basically says get more data and don't work in areas that don't have lots of data because you're wasting your time. And of course, all of us don't believe that because we're trying to solve the problem, not trying to do the problem that is possible with today's machine learning. So what are the consequences of machine learning when we're working in areas where, so almost by definition, we're always going to have not enough data? And are there things that we should be doing or helping or encouraging the machine learning modeling people to care a little bit more about the types of data and the types of problems that we're working with? So this time I'm going to start with Gopala because I believe he has something more in this area. And I'm going to do Emily, Odette, and then Sakti in that order so that you know when you're coming up. We can't hear you, Gopala.
Oh, sorry, I thought I was, yeah, unmuted. All right, so on the computational modeling side, what can we do? Is that the question?
Yes.
Okay. Yeah, so I think I alluded to this before, that yeah, data is always going to be biased, and I'm reminded of the Stanford study on ASR, right? You have your major speech recognition algorithms that were tested on like the standard American English, whichever that is, however defined, and that would just not work as well for African American English. It was like twice the error rate across all the major players, Google, Amazon, Microsoft, and so on. And that's the nature of these models that we're building right now. And the more end-to-end we go, the more the data requirement these models have, and the more rigid and black boxy they get. And when you put in more data, the biases are amplified. So we need to somehow use the advantages that the current data-driven strategies like end-to-end modeling are giving, but also be mindful that there are aspects of variance, large aspects of variance, dialect, for instance, that exist in language. And we must think about ways to like have those biases be respected in the modeling. How do we do that? I do not know yet. But what I'm alluding to is the modeling must care about the large dimensions of variance which exist, so that while we are using big data and end-to-end models, there is room for improvement even after the modeling. So that's my initial thoughts. I may have more after the rest of the folks share their opinions.
Okay, thank you. Emily.
Yeah, yeah, this question is interesting. I think from my perspective as more in the linguistics side now, well, I'm currently doing some work to uncover or classify error cases of certain systems. And so I think my first answer to this is how can we use machine learning techniques? It's more of when you put it through a system, be very careful on how you analyze the errors, because there can be many different types. And so, for example, in the work that I've been looking at for forced phoneme alignment, we're trying to align sound units to the speech. I'm very broadly categorizing first as, okay, where was it more of a technical issue where the alignment kind of went off, or the aligner, or maybe the format tracker was kind of had some issues, versus where was it actual linguistic variation? So real language variation where people had a different accent, or maybe they spoke more quickly or informally than as opposed to formally, and that's what threw things off. And I think being able to identify, is it something that we want to model this more versus we want to kind of reduce that or model this less? That's a really important thing to think about. So that was sort of my first technical part. And then I was thinking just kind of a little more broadly, maybe the 2010s was the era where like, okay, we don't need linguists as much, but I think 2020s is very much so, right? We have all of our big systems and compute, but we want to be a little bit smarter about the data specifically. And so I think partnering, I know that David Mortensen out at CMU does a lot of really good phonological work, and not only that, but he works side by side with people that can implement these large models, or actually use some of the knowledge that he's putting out, integrating that into systems. So I don't know, I'm just thinking kind of broadly, more of a interdisciplinary type of work or collaboration, I think, is a strategy to help with these kinds of issues.
Thank you. Odette?
Yeah, so there are many things I want to say in answer to this question. So the first one is that so I agree with the point that has already been made both by you, Alan, but also by Emily, that I think we need more understanding of the variability in the speech itself. Simply throwing more data at it is not going to solve the problem, because I have a very, very strong feeling, and there is also some evidence that the methods that we're currently using, both for instance, voice conversion and automatic speech recognition, because those are the areas I've been working in most, have been primarily optimized towards typical speech and cannot actually generalize well to atypical speech. which means that we need to do something else. So when we look at all the research that we've been done in the past 2 years, and also looking at what other people have been doing, basically what you see is that if you look at the ASR pipeline, bias occurs everywhere. It occurs in the acoustic features. It occurs during training. It actually occurs in the architecture you're choosing. So if you're comparing end-to-end systems with hybrid systems, you'll see that the bias, if we train on the exact same data set, there are different types of biases that you can observe in different directions, different sizes. So there's in different languages have different biases. So there's a lot of variability in the bias as well, but it occurs everywhere. So that means that we have to be very careful about how are we going to try to remove or at least reduce the bias in these different systems, and that is dependent on the architecture and the language, etc. So one of the things that we've been looking into is different types of, on the one hand, data augmentation, because we're working in a low resource setting, and on the other hand, looking at a way of using the available data in a smarter way. So by trying to, while training the system, try to maybe get representations that allow for instance, our work, native and non-native accents to be both be recognized better. So one of my former master students will be presenting this work in about an hour from now, I believe. But if you look, for instance, at data augmentation, there are also, again, 2 types of data augmentation, broadly speaking. On one hand, simply creating more data from the speech that you already have by speech perturbation, by pitch perturbation, etc. But you can also try to create more data that's similar to the type that you already have, for instance, by using voice conversion to create speech that has the characteristics of the type of speech that you're trying to generate or trying to model on, actually. Rather than simply having more speech of the same speaker. So we're looking into finding different combinations of these different methods so that we can try to reduce the bias in all these different places along the ASR pipeline. Because by focusing only on a simple part, on a single part, you will reduce some of the bias, but actually there's far more to be gained. So that's just one part. On the other hand, work that we presented earlier this week at Interspeech, this was concerned with the voice conversion. Well, actually was concerned with ASR for dysarthric speech. What people often do is they take the dysarthric speech, do voice conversion towards more healthy sounding speech, and then do ASR. Actually, what we found was that if you use simple time stretching, so it's a technique from signal processing, you actually get results that are equally good compared to the best state-of-the-art voice conversion system that's currently out there for non-parallel data. So the other thing would be, the other suggestion I would have is to not forget about all the things that we've done in the past. Occasionally revisit all the techniques that we sort of now no longer en vogue anymore, but let's try and see whether they actually work for our current low resource settings, because as has already been said, current techniques need a lot of data, which you simply don't have. And data augmentation is great, but at the same time, we often don't really know what it is about the data augmented data that's actually causing the increase, if we're actually seeing an increase. Because one of the things that we've been finding as well is that when looking at different types of training methods, so for instance, so a DAT or a fine-tuning, multitask learning, these different types of techniques, they work really well on a particular task, according to the papers that originally proposed them, say, for instance, non-native speech recognition. But if you look at what they're doing when you try to look at the bias between a native accented speech and non-native accented speech, we see that there is indeed an improvement for the non-native speech, but actually more so for the native speakers, which means that the bias against the non-native speakers is actually growing. So even though we have techniques out there that work pretty well for certain tasks, they don't necessarily work that well for atypical speech, or don't work as well to reduce the bias against these different types of speech. And then also with what Emily was suggesting, error analyses are extremely important, trying to figure out what it is about the system that's not working, which part is not working, why is it working, what are the limitations of the particular technique, and then trying to focus on improving the technique at that particular point. And I think, that's it for now.
Okay, thank you, Sakti?
Okay, so yeah, I agree with all of you, and I think in this neural network world, we always do like data hungry, and then we need to do at the end like data augmentation. But we know also recently there's many approach that doing with the unsupervised learning, for example, with the zero resource speech technology, and also like self-supervised learning now is like everywhere in every paper. And also like semi-supervised learning that also deal with, I mean, not perfect with the pair data or non-parallel data. So more and more approaches are working on this issue that has been now widely been doing by many researchers. And also in this interspeech keynote speech, there is one keynote speech, I forgot the name. She talked about the David versus Goliath, and she mentioned like very important message that when we work, it's not always with the giant, you know, like how we compete with the giant that always with the big data and big resource or big GPU. And she said that her suggestion is that more smart, like more use the knowledge, and then it turned out that she proved that it's somehow better than just using more data. So I think it's more important that we need to use also the knowledge, not just a black box and put the data, but also in the other discussion, I think I forget in which keynote also there is a discussion that the problem is that recently more and more students, they just like, okay, use this data, open source, and then we are not really like, I mean, in the past, we really need to work what is the speech production, how to deal with this one, how to work with this. So we know all this knowledge. While recently we just like, okay, pick up this data that's already open source, pick up this model that's already open source, and then you just plug in your model. It doesn't work, just add more data. And then in the end, yeah, we don't know how to solve it rather than just adding more data. So then I think we need to back, like maybe we need to learn and then put more knowledge and how build more simple model that more smarter than just adding more data, I think.
Yeah. Odette?
Can I add one more thing, because of what Sakti is saying is absolutely true. One thing that also struck me while in interspeech is that quite a few people don't really know what the parameters are for different techniques that they're using. So for instance, there was one paper just simply plugging in spec augment with the standard parameters for English, for some other language, and spec augment didn't do anything. To put it really bluntly, maybe we should try to get more science into speech technology again, and not science in terms of speech science, but rather research question driven science, and also trying to understand the techniques that we're using, not simply taking off the shelf, not only off the shelf data, but also simply take the off the shelf techniques and then just applying them and see whether something works. I mean, for a long time, maybe that was the way to go, but currently with the current techniques, better understanding what the techniques actually do and what parameters one can tune would probably also help quite a bit.
That's unquestionably true.
Sorry?
Yes, unquestionably true. You know, having people understand about the techniques, I think, is important, because there are reasons for these techniques of why they should and should not work. Yeah.
Yeah.
Are there any questions from the audience for the panel? Okay, so while people in the audience might be thinking of questions, let's move on and do another question.
There's a question, Tanvina.
Oh, there is a question. Oh, yeah. Tanvina, go ahead.
Hi. Hi. Since the conversation is already going on speech science and data, I just wanted to know your views on the big pre-trained models that are coming now. So just few years back, wave-to-wake was nothing. And since it has just a big pre-trained model is available, what the ask has become is just train your model on the wave-to-wake, fine-tune a model with wave-to-wake, and you get your ASR. Just 3 days back, OpenAI launched their 700,000 hours of ASR system. So although it's like we say that we want to like learn about speech science, speech technology. But what happens even when you write papers, we get a general comment. Have you compared your approach against wave-to-wake model? So although we try, there's a shift that is happening because of so much data, so much heavy, what do you call, heavy big models out there in the open source. And not only that, even if you try, it's difficult to like ignore that part, because even students, when they come, they want to learn that, they want to use that. They previously, like how we used to do when we started doing a PhD masters, we were interested in format, pitch, etc. And now they're interested in how to put that model first and how to get the toolkit running. So there is a shift. Though we want to preserve it, it's still happening. And I don't know, I don't know if we can ignore that or something. So I basically wanted to know the views on that. I mean, there is something that is coming up. I see after a few years, it will not be about data, it will just be about compute. Do you have the compute to just pretend something with XYZ approach and follow the same thing, replicate the same because something is available there in the market, which is giving good results? So I have seen, people with speech science are given less important. Obviously in industry it is there, but even in academia, I see the shift students, it's happening. I mean, they have, as Odette said, they have less knowledge about what was there, what is actually the parameters and things like that. More of taking things and getting getting it to work somehow. So I just wanted some views on that.
Okay, thank you. Would any of the panel like to answer that?
Okay, I'll take a shot. I agree. It's completely true. It's hard to get students to see that things that are in vogue in the industry and what's the catchy, flashy titles capture is not great for like research. Because it's something I think people in academia, students should realize is, if your technique is going to be, again, big data and big compute and tricks on data and compute, you're never going to beat the big guys. And so I think the onus is on the academia to think out of the box and to see what they can do that's different, that industry wouldn't care about. That's what all these big ideas have come from, is like out of the box thinking from academia. So I think students should keep at it and then try to push this push the things that industry is currently not caring about, because that is where the next breakthrough is going to be. So it might feel like a lull in terms of science, but I think things are plateauing. Like you see the big models have done what they've done, but they lack fairness, they lack robustness to bias and so on. So I think, yeah, the onus is on academia to think out of the box and yeah.
Odette?
So yeah, I agree with what Tavina was saying about the students, because Tavina and I supervise students together. So she's the postdoc in my group. But what I want to say is that, so these pre-trained models, they sort of take out the science out of our research. At the same time, we also see that with, if you take one of those models and you do a bit of fine tuning, you do actually get, for many different tasks, you get pretty good results. I mean, it's hard to beat them at this point in time. So I think they could be, a savior for quite a few tasks that are currently low resource. At the same time, at Interspeech this week, I was at a talk where the newest multilingual model was presented, Wave2Vec 2.0, but then the multilingual version of it. And they threw an awful lot of extra data at it. I don't know, we talk about billions at this point. And they got quite an improvement on, I don't know, about 6 different downstream tasks. So I would say that, that was pretty impressive. So, but when I asked the question, so do you know whether it's the increase in data or whether it's the increase of, or what is the diversity of languages? Because the language that they added were like really low resource languages, a tiny bit of data compared to all the other data that they were using. Do you think that the languages played a role? And if so, what do you think would be the best group of the best set of languages to add to the training data in order to improve the system? And there was simply no answer to the question, which to me really gives me the idea that these pre-trained models that we have, they're absolutely useful. They are. At the same time, the way they have been trained, that can be improved upon, because it looks to me, at this point in time, at least, based on the interaction I had with the presenter there, that it's simply that they're really viewing speech as a type of data rather than the data it actually is, so the signal it actually is. So they're completely forgetting about that. So I think, so yes, we cannot ignore the big models, but they will not solve the problems that we currently have for low resource speech types and low resource languages. So if we want to deploy speech technology in a wider context, we really need to move beyond the big models or try to collaborate with them so that they can actually improve upon the models further.
Sakti, Emily, you have anything to add?
Okay, so I think one thing that's sometimes a problem that when we have students that usually to graduate, you need to publish a paper and publish a paper that you just need to be, with all those things. So at the end, you need to use those things and then make a better improvement. I mean, sometimes the problem is that the reviewer of the paper, sometimes they just, oh, you don't compare with this one, so your result is not good, for example. Rather than we need to respect if there is a new things like a new technology that they develop, even is not in the state of the art, right? So yeah, but I think the reviewer itself now is still also in the discussion that it's not always it's not always like we have to be state of the art, but we need to see the technology. So I think that we need to see in this both sides, so it's not just so not just the paper that have just put big data and then reach like very good performance compared to like maybe more academic, more science, but maybe not yet result in the best performance.
Emily, do you have anything to add or not?
I've just been taking notes of everyone's comments here. I'm learning, so I have nothing to add here for this. But excellent question too. Thank you.
Thomas, do you want to ask your question?
Evening from Korea. So I feel like it's a good thing that we started to worry about this, but we might not be the people who should really worry about it. So I feel like there is a rift right now between industry and academics. And we are worrying about this, but really Google and Facebook and the other big guys should be the ones who needs to be convinced to worry about this different biases. And they are the ones actually who have products that are sort of connected to the users already. So basically the people are already exposed to these biases. So one big question that I have no idea how we can do that is how we can convince these big guys to actually care about this issue. And then the sort of follow-up for the data problem. So we also fell into the problem that we collected whatever data we could, and then we got a lot of data. But at least we tried to create the evaluation set as balanced as we could, even though the data was absolutely unbalanced and it had a lot of biases. So the question is, should we try to push for or advocate for like guidelines or some templates, how to create your evaluation data? Because right now I feel like a lot of groups and a lot of companies just randomly select whatever data they want, and it still has a lot of biases, and And another sort of question is, should we ditch the single number evaluation metrics, like word error rate in speech recognition could very easily hide biases? And should we go for like a distribution of word error rate across different groups? Sorry for the very long line of questions.
No, that's an interesting comment and direction. So again, let us open up that to the panel about, is there a way to mitigate people's own biases in building systems by enforcing, encouraging, penalizing when evaluation sets are maybe not addressing the distributions that you would like, rather than the data sets that they actually have? Odette?
So I know that Google is actually working on this. Meta is working on this. Amazon is working on this. So there's quite recently were at least one, maybe two papers from Google out that were actually looking into different ways of evaluating ASR performance. So I know that these companies are working on it. At the same time, what I'm not sure about is how well these research within these companies actually connects to the people who are actually building the systems that are out there and being used by customers. So for instance, so I had a talk with Amazon Thursday evening exactly about this topic, because they realized that we have to do something about bias, and quantifying it and trying to mitigate it. So they work on it, and Dan van Es is one of the people who's primarily from Google, who's primarily involved with finding different ways of evaluation. So I fully agree that these are the ones. So these are the big guys, as someone is saying, that need to be aware of it. So I know that within these companies they're working on it, but I don't know how much influence they actually have regarding their product. Regarding word error rate, likely word error rate is not the right evaluation. So what we've been doing within our group is not to report word error rate across a test set, but rather we look at individual speaker groups within our test sets and then see how well they compare to the normal or typical speakers, and see what that gap is, and focusing on reducing that gap between the two speaker groups, so the typical and atypical speaker groups. But that we also know that Savina is currently working on this together with the PhD students from another faculty at TU Delft. So trying to find a way of, can we come up with a different definition of bias? So how can we actually, what kind of metrics should we be using to quantify the bias? Because we know there's a gap between typical and atypical speech, but word error rate itself also says something. And there was an interesting talk at Interspeech about Norwegian, where they were also looking into defining different metrics, but then focusing on semantics. So apparently in Norway, you've got two writing systems where about 75% of the language is written in one writing system, and the other 25% in another writing system. So the ASR will actually get the word correct, but will use the word from the wrong language. So the word error rate is higher than it actually should be. So they're looking into semantics. So if the decode message has the correct semantic meaning, then we're penalizing it less. So some people are working on trying to find a new way of evaluating our systems, but it is really crucially dependent, as Thomas was also saying, on the evaluation set that we have. So one of the things that within a project that I'm currently running, together with Savina is part of that as well, with Johns Hopkins University and the University of Illinois, we're also trying to, one of the goals there is to come up with an evaluation set. And we're going to obviously also organize a challenge surrounding that, so that different people, companies, researchers, institutions can use the same evaluation set to see how well the systems are working in terms of not only performance, but also bias against different types of non-standard speaker groups.
Anyone else on the panel want to make a comment here?
I just want to speak to Tamash's first part, which is we shouldn't be the one caring about and companies should. So companies actually, like Odette also pointed out, the researchers who are building the tech actually know deeply what the flaws are, what the limitations are. But the press offices of these companies really put out press releases that are totally overblowing the results, or like they claim human parity where there is none. So I think it's very hard for grad students to see through these different layers of messaging. So I think in their heart, the research groups in these companies have the right intent, they know their limitations, and they're very collaborative as well. If you reach out, and they know what your models can and cannot do. So I think, again, back to my earlier point, the big data and the big compute models are great for academia in one sense, because that's kind of the dirty work that's already being solved. So what's left is the interesting things that all of folks here are caring about. So people who are interested in doing real speech technology don't have to worry about building the big compute and the big models, because they are done and for free, right? So use that as an opportunity rather than as an impediment to beat, right? So use that as the best case scenario of what a brute force model could do, and then think about how you can do better, or aspire to do that with lesser resources, simpler models, interpretable models, debiased techniques, and so on. So yeah, just that comment in response to that.
Yeah, just to add a little bit, yeah, I agree that I think this with the big company and then this big model is not let's make it as an opportunity, especially in this everything's now is open source. I think if we compare in the past, it's almost none is open, right? So now it's the data is open, the model is open, so we can just try. And for example, in terms of the evaluation, word error rate is not optimum, and so I think this is the way chance that we need to find a better evaluation that that can make a better system for testing. For example, in the past, I did an EEG on the error of so the human see the sentence when there is a deletion, insertion, and substitution. And actually the effect is different when it's insertion, deletion, and substitution, because when it's insertion, the whole sentence is still there. So the effect is not too much, but when it's deletion, like this, the effect in the EEG is quite far. And so the weight is not the same between substitution, deletion, and insertion. But then, so yeah, I do like a weighted word error rate and things like that. I think there is also several studies that also try to make a better evaluation, but still, like people just use the simple one. In the end, it's still word error rate that is commonly used, but it doesn't mean that it's the best. So that's why it's the way that the research is not yet finished.
Okay, thank you. As we're running out of time, let's move to the final question. Sorry, Satwik, we're not going to have time for your question. And I'm going to have a presupposition in the question that we, working in this field, want to encourage graduate students to work in this area. So I'm going to ask each of you to give your sales pitch to incoming students about why working on social good aspects for speech, low resource languages, medical aspects of speech is a good and important thing to do. Okay, so we're going to start off with the one who can remember being a graduate student best, and that's Emily. And so, Emily?
Yeah, this is a good question as I'm thinking about hiring grad students maybe in the future. So I guess a couple things. The thing that I think I first landed on was, if you're starting out a new career, or I was kind of restarting my career like 3 years ago, asking myself or asking the students, what kind of speech technology do you want to see in the future, right? Yeah, just like dream big. And I think for me, my whole journey in this research field started very small, silly a simple question where, you know, I was just wondering, what if Siri could actually understand my Cantonese grandpa's, you know, English, right? He has a strong accent. Like, what if it could actually understand what he was saying? And then it led into like some non-native accent ID work I did in the undergrad, and kind of just, it was a fun topic, but I think it was a really interesting thing for me. So I would love to see speech technology that can work for my grandparents, right? That are multilingual speakers, or so that's kind of one aspect. Yeah, I guess in terms of linguistics, I had just hired a few undergraduates to help me with my work in the spring quarter. And they needed no convincing that languages were cool and that we wanted to make this work for all of these small languages in this data set that we were using. And so I don't know, I haven't had any problems there getting them to buy into, why should we work on this kind of weird project with Emily? So I think, I'm not sure, people that really do value language and can see the people that are going to be speaking it and envision what's going to come next. Those are all things that I think would be good to promote.
Okay, good. Sakti?
Okay, so in the past, I have one student who proposed to build a dialogue system who can angry to user. And then when I asked why you propose a dialogue system who just angry, and she said that because it's fun and it's novel, because there is no dialogue system who is just angry to user, so it's a novel. So I said that, you know, when we build technology, it's not just fun and new, and then because we build for a future, right? It's different than a doctor. Doctor is solving what the disease that has been there, but we are doing with something that is not yet exist. So then we realize or not, we are the one who responsible of what kind of world that we will live in the next 20, 30, 50 years, right? And I said that you imagine in the next 50 years, do you want to live with the robots that always angry to you, or do you want to live with robots that help you? And then, yeah, you can imagine that you prefer the world with many robots that help people. And that's it.
Angry robots, yes. Good. Gopala?
Yeah, so why should students work on this? Well, I alluded to this already. The easy problems, you know, are all solved, but if you really want truly conversational systems in the real world, they have to, the current way of doing things just doesn't get you there. What's remaining is these hard problems, this long tail of atypical speech, you know. So that's where when the product groups and this executives making these decisions don't see these systems and algorithms making money, they'll push the companies to think out of the box and make it work for everybody. So I think there is real money in working on this. But I had an intern, anecdotal. I have a student who just interned at a big company, and he was all about like the big, flashy, big models. But after he did his internship, he truly realized that there is a dearth of ideas at the companies, right? So he came back with an appreciation for, you know, more grounded scientific research. So I think if you actually work at the company, you realize that, okay, it's not as glittery inside. And you really want, if you really want to have the experience of doing something new and novel that you're proud of, and that'll actually pay you a lot more in the years to come, then this is where you want to be.
And Odette?
Okay, yeah. So I would say that we live in a world that is increasingly digital. So, you know, especially in many Western countries, especially in the Netherlands, anything you want to do, you have to do it online. It's really, really hard to actually talk to a person. But there is also, and for instance, in the Netherlands alone, 10% of the adult population or native speakers of Dutch, they are low to illiterate. So there's a huge problem for them. So ASR could really, really be beneficial, because if people could just simply speak to a computer to help them fill in the form, and that would be really helpful, because they don't have to worry about having to type themselves. The problem, though, is that for many of these people, they are the ones for which ASR actually doesn't work. At the same time, people, so the government in the Netherlands is pushing elderly people to live home longer. But they're getting fragile the older they get. So you want to help them. You want to be able that they can use their voice to, for instance, open the curtains, turn on the thermostat, or to call for help if they've fallen down. People who have a paralysis, they can use their voice as well. Typically, for these kind of people, ASR does not work that well. So why do we want to work in Speech for Social Good? Because that's where we can actually make a huge difference. We can really make a difference for these kind of people who are currently being left out of society often even, and help them be more included in society and actually participate in society more, so they can get represented better as well. Because these people, because we don't hear about them, laws are typically not being made for them either. Rules are not being made for them because they're not being represented. So I think that we can really make a huge difference by focusing on these atypical speaker groups. That would be my sales pitch.
Okay, thank you. And that's all good, and I hope this encourages students to see why this is a good area to actually work in. So that brings us to the end of our panel this morning, if it's this morning for you. And so first, I'd like to thank the panelists. And so thank you. I'll pass you back to Anurag for the, we'll probably have a short break here before we start the first paper.